Hello, geometry students. Welcome back to another video lesson. Today, lesson 5-3, one-step congruence proofs. So we really going to be looking at proofs, looking at the evidence that allows us to say one thing is true because of what we might be given. So the goals are really to make and justify conclusions about congruence figures and prove when distance and angle measure are preserved in a pair of figures when they're congruent. And so it's really knowing a lot more about our theorems, proofs, definitions. Okay. So here's what the first example kind of looks like. The segments below, AB and CD, have the same midpoint, M, as shown down below. So segment CD has the midpoint M. Segment AB has the midpoint M. In other words, if we were to draw some marks on here, this segment is congruent to that segment. And then this segment down here, A to M, is the same as M to B. Okay, so it's two lines that are intersecting. And then we've got some A, B's, and C's, which we're going to use right in this. Which statement from this list, from A, B, or C, allows us to state this is true? So number one says the measure of angle AMC plus the measure of angle CMB equals 180. So AMC, which is this one, plus CMB, which is this one. What allows us to say that they equal 180? Well, they are adjacent. And if they're adjacent and they're next to each other and they create a straight line, we call that a linear pair. So this is going to be C. Angles in a linear pair are supplementary. Okay? Angles. And so that's just using the definition of linear pair. Number two, the measure of angle AMC, which is this angle right there, AMC, how do we know that's equal to the measure of angle BMD? BMD. Well, that's part A. We call those vertical angles. Vertical angles are going to have the exact same measure. That's the measure. How do we then go from saying their measure is equal to those two angles being congruent? If two angles have the same measure, then they are congruent. That is B, or the angle congruence theorem. Okay, and so these are all justifications, evidence of what's happening here based upon some of that given information. Now, how do we look at this in a more broader context? So here's question number two, where we've got to use some background knowledge. If we are given the following, that points A and B are on a circle, and that circle has a center O, what can we conclude about the distance from OA and the distance from OB? What can we conclude? So we draw a circle, and I'm just going to draw it over here. I have a little bit more room, and we'll just make it white. Okay, and it has a center, which they are saying the center is point O. If I put A right there, and I put B, say right here, what statement or what can we conclude about OB and OA? Well, we can say that the distance from O to A is the same as the distance from O to B. Those are both called a radius of the circle, right? Radius. We're allowed to say that because of the definition of a circle. The definition of a circle says any point that's on the circle is equidistant from the center of the circle. So even if I put another one way over here and I labeled it as C, I could also say that this segment, O to C, is the same distance as those because it's also on the circle. Definition of a circle. So how does this work in setting up our proofs, right? How do we work through these different steps? Okay. So we are given this fact. Triangle ABC is congruent to triangle DEF. We want to prove that the measure of ABC is equal to the measure of DEF. So we always start with the given, right? So this should always be our first justification. Easy point, if you remember to write this down, that first blank right up here on the justification column will always be given. Then we can say that angle ABC is congruent to angle DEF. If the triangles are congruent, then the corresponding angles are congruent. What allows us to say corresponding parts are congruent if the figure is congruent? That would be CPCF, corresponding parts in congruent figures, CPCF. Right, so I had the triangles congruent. I can then say the angles are congruent. CPCF, if I have that the angles are congruent, I can transfer that to say that the measures are equal, because if two angles are congruent, then they have the same angle measure. That is the angle congruence theorem, right? Going back and forth between being congruent to their measures being equal. So that's slowly what we're getting into. We're working into these 1 to 2 step proofs using justifications that allow us to change the way something looks. Here's example 4. Given that ray BD bisects angle ABC, we want to prove that the measure of ABD equals the measure of CBD. So let's just draw this angle right here. Here is A, B, C. We are given that, and then we're also told that this ray right here through D, that it bisects. Well, what does the definition of bisect mean? Hopefully you recognize that it means that these two then would have the same measure. So what do we start out with? Well, if the justification is given, we need to rewrite that as a conclusion. BD, right? We are assuming this to be true because it's given. Ray BD bisects angle ABC. If it bisects it, I then know that this angle number 1 and this angle number 2, their measures have to be equal. So the measure of angle A to B to D has to equal the measure of the angle C to B to D. All right, I can say that about their measures right away because that is the definition of an angle bisector. The definition will always tell us that two measurements of an angle are equal. The definition of an angle bisector. Right? If it cuts it in half, the two measurements have to be equal. Last one. Let's take a look at one more. Here we go. We got to write it. Given that the measure of angle 2 is equal to the measure of angle 4, we need to justify that x is parallel to y. That x is parallel to y. So we're going to start with the given. The measure of angle 2 equals the measure of angle 4. What allows me to say that? This is the given. Given. So if I look at the diagram, that means this angle right here is congruent to this angle right there. So what does that mean then? Try and think for a moment. What do you think that means? Hopefully, you can remember that if corresponding angles are congruent. Number 2 is in the same spot as number 4. If corresponding angles are congruent, that means these two lines are parallel, or that X and Y are parallel. So that means I can say line X is parallel to line Y because of the corresponding angles postulate. This was something we wrote down way back when we did this chapter. Corresponding angles postulate. Okay, and that postulate, it says if two corresponding angles are congruent, if they have the same measure, then the lines are parallel. Or the other way, if the lines are parallel, then the angles have to have the same measure. Corresponding angles postulate. So make sure that you've written that down. If you have any questions about what some of these justifications are, you got to make sure that you reach out and ask. We want to start making sure we have a list of all of these proofs and theorems and justifications and reasons that we can say things are true. Try and work on the practice on your textbook today. And if you have any questions, make sure you reach out. Otherwise, until next time, everyone, stay safe.